All right, so let's do a quick review of the week 58 through 71. Okay, so let's see. Question number 58. For 58 and 59 says factor the common factor out of each expression. So this is where we kind of start looking at the greatest common factor. And I'm looking number-wise, 100, 190. What's the biggest number I could divide them by? I'm going to say 10. Letter-wise, can I factor out a letter? In order for me to factor out a letter, they all have to have it. And I use the lowest exponent. Now, in this case, I cannot. So I'm just going to open my parentheses. I'm basically doing my distributive property backwards. Each of my numbers, let me divide it by 10. So inside, I'm going to have 10x to the 7th plus 10x plus 9. I divided each by 9. I mean by 10. Well, this is x to the 7th. Looks like a 2. That's it. I basically did the distributive property backwards. Let's take a look at number 59. Number-wise, I feel that I can divide them all by 4. Letter-wise, they don't all have an A, so I'm not going to be able to remove an A. So I'm just going to divide everything by 4. So it's going to give me 9, A to the 5th, minus 1, A to the 3rd, minus 7. Okay, that's it. Then we start moving into factoring. First, we did grouping. You know, what happens when there's 4 terms? So I'm going to look at 2 terms at a time. Looking at the first 2 terms, I feel I can factor out a 4, p squared, right? I can divide everything by 4, and I can remove p squared. I go by the smallest exponent. All right, so each number I'm going to divide by 4, and from each exponent in the p, I'm going to subtract 2. So I'm going to have 1p plus 7. All right, now looking at the last 2 terms, I feel I can divide each by a negative 7. So that's going to give me p plus 7. Now my factors, one of them is p plus 7, because it's the parentheses that repeats. Let me highlight that here. My other parentheses will be 4 p squared minus 7. Basically what I have on the outside. When we write this, which parentheses comes first, it doesn't matter. The rule says we have to have both. Doesn't matter which one comes first. All right, let's move on to question number 61. By the way, I'm working up until 71 today. So question number 61. Again, I'm looking at, because there's 4 terms. I'm going to look at the first 2 terms only. Number-wise, 24 and 8, I can divide each by 8. Letter-wise, I'm going to factor an x squared out. Right, I go by the smallest exponent. So that's going to give me 3x minus 1. Notice how each number I divided by 8. Letter-wise, I removed 2 from each exponent. All right, now on the last 2 terms, 21x minus 7, I can divide each by 7, by a positive 7. So it's going to give me 3x minus 1. So my factors are going to be 3x minus 1. That's from this common parentheses. Right? My parentheses have to match. And my other parentheses will be 8x squared plus 7. Okay. But then we moved on to, what if we have 3 terms? What if I have trinomials? To begin with, my first number is going to be a 1. Right? That was the easy one. So we're like, all right, what if I'm looking for 2 numbers that multiplied equals -6, but when I add them is equal to -1. You can see where my -6 and my -1 came from. All right, so 2 numbers that multiplied equals -6, but when I add them is equal to -1. So I'm going to think of -3, +2. okay? Now I look at the first one here. My exponent is x to the fourth. And I think, what's the half of 4? Well, 2. Okay, so each of my parentheses is going to start with x to the 2. Notice how my exponent, I cut it in half. So if my first one was x to the second to begin with, I'll split it as x and x, right? I split it in half. Now my parentheses, one of them is going to finish with a -3. The other one's going to finish with a +2. You see where I got those from. That's it. Now, what I mean with this, if my question was x squared minus x minus 6, okay, so I know my parentheses will finish with a -3 plus 2, but in this case, it's just x and x, because I start here, x to the second. Okay, the exponent is 2. What's the half of 2? 1. So notice how I split the exponent. I split it. Okay, let's take a look at one more example here. So, okay, there's not a 1 at the beginning. There's a 2. Maybe I can make everything smaller if I divide everything by 2. And that's going to give me x to the fourth minus 5x squared minus 6. Okay, so I was able to have the leading coefficient, right? The first number to 1. So then I'm thinking two numbers that multiplied equals -6, but when I add them is equal to -5. Well, -6, +1. So I'm going to do my two parentheses, and I'm going to say one of them will finish with a -6. The other one will finish with a +1. But I look at my exponent here, the x to the fourth. I have to cut my exponent in half. So I'm going to do x to the second, x to the second. Don't forget this little 2 at the very front. Notice how that was a factor to begin with, so don't forget that one. But then we move into this one, 64. Huh. I want the first number to be a 1. Can I divide everything by 12? Not quite. So in this case, we're going to think of two numbers that multiplied equals -72. My -72 because I multiplied those out. So I'm thinking of two numbers that multiplied equals -72, but when I add my numbers, it's still -1. My -1, I got it from right here. So in this case, we will think -9, +8. Okay, so now this is just how I'm going to split my middle term. So let me write this as 12x to the fourth minus 9x squared plus 8x squared minus 6. Keep in mind my -1 at x squared, I split it as -9x squared plus 8x squared. I split it, so I will have 4 terms. When I have 4 terms, I look at my first 2 terms. 12 and 9, I can divide each by 3x squared. All right, so let me divide each by 3x squared. That's going to give me 4x squared minus 3. All right, looking at the last 2 terms, I can divide each by 2. And that's going to give me 4x squared minus 3. As a matter of fact, let me call it a +2, right? I factor out a +2. So let's take a look. My parentheses, one of them is 4x squared minus 3, and the other one is 3x squared plus 2. When my first numbered is not a 1, I have to split the middle term. All right, let's take a look at number 65. Can I divide everything by 10? No. All right, so I'm looking for two numbers that when I multiply it is equal to 90, but when I add them is equal to 21. The 90, again, I multiply 10 times 9, and you guys can see where I got the 21 from. Now, you cannot think like right away, oh, which numbers are those? Think of the multiplications of 90, the factors of 90, which are 1 times 90, 2 times 45, 3 times 30. Notice how my list on the left, I keep on increasing, right? I keep on increasing by 1. Now, is 4 a factor of 90? I do in my mind, I use a calculator. 90 divided by 4. And if it gives me a decimal, well, no, it's not a factor then. I know 90 divided by 4 gave me a decimal, so nope, 4 is not a factor. Can I use 5? Let me do 90 divided by 5 is 18. Okay, so far none of these numbers add up to 21, right? So then I think, what about 6? 90 divided by 6 is 15. So I know 6 times 15 is 90. 6 plus 15 is 21. That's how I know which two numbers I'm looking for. All right, so I'm going to split my middle term. So let me go 10 m to the 4th as the first term. Now for the middle term, let me do plus 6m squared plus 15m squared plus 9. Now that I have 4 terms, let me take a look at the first two. 10 and 6, I can divide each by 2. Letter-wise, I can factor m squared out. So that's going to give me 5m squared plus 3. Now looking at it here, 15 and 9, I can divide each by a positive 3. So that's going to give me 5m squared plus 3. Now my parentheses are going to be 5m squared plus 3 and 2m squared plus 3. Ah, nice. Now question number 66. Oh, this is a special case. Remember, there's only 2 terms. I can write everything as 2x. We talk about special cases already. 2x all squared minus 3 squared. Can write this as a minus of 2 squares. So we call this the difference of the squares. We talked about this before. So one of my parentheses will be 2x plus 3. And the other one's 2x minus 3. One of them has a plus. The other one has a minus. Take a look at number 67. I feel I can write everything as square. So 3x all squared minus 4 squared. So one of my parentheses will be 3x plus 4, and the other one 3x minus 4. Now looking at number 68, I can do the diamond thing. Two numbers that when I add is equal to 24, and when I multiply it is 144. Right, 9 times 16, that's where I got the 144. That can work. However, let me check if this is a special case. I can get the square root of the first term, and I can get the square root of the last term. The square root of 9k squared is 3k. The square root of 16 is 4. I'm going to say this is a special case if 3k times 4 is half of 24k. Yeah, 3k times 4 is 12k, which is the half of 24k. Because my middle term is a plus, let me put my plus sign here. And this tells me I'm going to have 3k plus 4 twice. So when I type this, I'm going to go 3k plus 4. Have it twice. 3k plus 4 2 times. The diamond method, let me highlight this. This will work. Right? You will have to split this as 12 and 12. You have to split the middle term, but you will end up getting 3k plus 4 twice. Let's take a look at question number 69. Let me get the square root of each to see if it's a special case. 9x squared, the square root of that is 3x. And then the square root of 4 is 2, right? I'm getting the square roots. 3x times 2 is 6x, which is half of 12x. Okay, so it is a special case because my middle term has a minus sign. I'm going to respect this, and I'm going to get 3x minus 2 twice. So when I type this, let me go 3x minus 2 and 3x minus 2, right? Twice. Now, question 70 and 71, I see everything to the third. Let me rewrite everything to the third. So a to the third minus 1 to the third. I have to rewrite everything to the third. My first parentheses is going to be a minus 1. My second parentheses, okay, so this starts with an a, multiplied by itself. A times a, my second parentheses was going to start with a squared. Here, 1 times 1, so my second parenthesis is going to finish with a 1. Now my middle term is the one that's different. So there's a minus here. So my middle term is going to have a plus. And then let me multiply it 1 times a, which is just a. All right, let's take a look at number 71. Let me rewrite everything as 2m all to the third plus 1 to the third. I rewrote everything as to the third because of the plus sign in between. So my first parenthesis will be 2m plus 1. Now my second parenthesis, it is going to start with 4m squared, and it's going to end with a plus 1. My middle sign will be minus, and then it's going to be 2m. Beautiful. Now let me zoom out. That's what we did.